Alright, question 8. Question 8 asks you to express another set of partial fractions. So it was 16 plus 2x plus 15x squared all over 1 plus x squared times 2 minus x. I'm not too sure how the book does this, but I was in the habit of starting with the highest power of x, so I just did that sort of an autopilot. They use this the other way around, so use like a plus bx. Anyway, it doesn't matter. So I can say therefore 16 plus 2x plus 15x squared must equal ax plus b times by 2 minus x plus c times 1 plus x squared. And again, I would equate coefficients. So we're going to have x squared. Well, x squared is 15 in that case. And on the other side, we're going to have a minus a plus c. So in other words, you can say c is equal to a plus 15. We'll call that equation 1. Right, x to the power 1, equate that, that's going to be 2 is equal to, and then on this side we're going to have a 2a, and then we're going to have a minus b. B times minus x, and there's no x squared, x coefficient here, so we're going to have 2a minus b, and call it equation 2. And again, you could write that as, let's say, 2a is equal to b plus 2. We'll see if these are useful later on. X to the power 0, you've got here 16. And on this side, we're just going to have 2b, and then we're going to have plus c. So it's going to be 2b plus c. We've got equation 3. Or we can write c is equal to 16 minus 2b. Now if I take this equation for c, and I take that equation for c, I can say that a plus 15 must equal 16 minus 2b, and then I can say a plus 2b must equal 1. We'll call it equation 4. And here I've also got an equation involving a and b, so I can say 2a minus b is equal to 2. And that was equation number 2. And if I just double that, I'll get 4a minus 2b equals 4. That's called equation number 5. And if I just add together 5 and 4, I will get a and 4a is 5a. 2b minus 2b is nothing, so that's equal to 5. So therefore, you can say a equals 1. Now coming back to this equation here, a plus 15 equals c, we can say therefore c must equal 16. And here we had 2a is equal to b plus 2, so a is equal to 1, so b plus 2 equals 2, so b must equal 0. So going back up to the top here, a is equal to 1, so that's just x over 1 plus x squared plus, and then c is equal to 16 over 2 is x. And we've shown what we're asked to show. They said show x a equals 0 because they had a to be the one that was by itself. We've got b equals 0, it's the same thing. So that's where we need to go from there. Alright. So I'm just going to rub this off and we start the next bit of the question. Alright. Okay, so you're asked to do the integral of this f of x between 0 and 1 of, so we can say this is f of x dx. So that's going to be equal to the integral from 0 to 1 of this. So it's going to be x over 1 plus x squared plus 16 over 2 minus x dx. Alright, that's equal to Now, in this first question here, if I've got this first question here, it's salmon. No, it's a maraschino here. Let's see. Right, if I have x over 1 plus x squared, if we said u was equal to 1 plus x squared, then du by dx would equal 2x. So du would equal 2x dx. So therefore x dx must equal du of 2. Right? So this is going to equal, I can go straight away and write, this is going to be 1/2, right, of log 1 plus x squared. And then if we consider 16 over 2 minus x, again, if we let u equal 2 minus x, then du by dx is equal to minus 1. So du is equal to minus dx. I don't have a minus dx here, I've got a 16 dx. So I can say 16 dx. So I've times this by minus 16 essentially. So I'd have to times that by minus 16. So that's going to be minus 16 log of 2 minus x. Right, there we go. Now we can evaluate that. Well, we can rearrange that. We can rearrange that. That's going to be the log of 1 plus x squared square rooted minus the log of, we can say 2 minus x to the power of 16. And that's the same as the log of 1, the root of 1 plus x squared over 2 minus x to the power of 16 mod. And this is all between 0 and 1. Right, what have we got now? It's going to be equal to the log of, now we're going to put 1 in here. 1 plus 1 squared is 2, so that's root 2 over 2 minus 1 is 1 to the power of 16, so that's just 1. Minus the log of, 1 plus 0, that's going to be root 1, so that's just 1 over 2 minus 0 is 2 to the power of 16. So that is going to be equal to, let me go back to yellow, that's going to be equal to the log of root 2, so this is the same as, this is log a minus log b, so that's going to be the same as log a divided by b, so log a over b. If we divide by a fraction, that's the same as multiplying by the reciprocal. So that's going to be, and I'm going to write this root 2 as a power of a half, because it's going to be easier for me. So it's going to be equal to the log of 2 to the power of a half, and then it's going to be times 2 to the power of 16, because that's the same as dividing by the reciprocal, which is going to equal log of 2 to the power of a half plus 16. 16 is 32 halves, so it's going to be a log of 2 to the power 32 halves, which is the same as saying 30. Sorry, my apologies. A half plus 32 is 33, which is the same as saying 33 over 2 log 2. Alright, and that's that part of the question done. That's that part of the question. That was you asked to find the exact integral. The next part of the question asks you to express the partial fraction as an expansion to the power x to the power 4. So we come back up to here, and we say this is equal to x times 1 plus x squared to the minus 1 plus 16 to the minus x. Now, just before you dive in, just be careful here, right? Because this is in the form 1 plus theta squared with 1 plus theta to the power n or whatever. This is not. So remember, you need to take out the factor of 2. So we've got 2 times 1 minus x over 2 to the minus 1, which is going to equal, I'll just put that back in, 16 times 2 to the minus 1 times 1 minus x over 2 to the minus 1. 2 to the minus 1 is a half, so 16 times a half is 8, so that's going to equal x times 1 plus x squared plus 8 times 1 minus x over 2. And these are, sorry, I keep forgetting to put the power minus 1 into these. My apologies. Alright, so now we need to use the expansion, and we're going to have to the power of 4. So leave ourselves a bit of space here. Right, 1 plus x squared, that's going to be 1 plus n is minus 1, so minus x squared, and then it's going to be plus minus 1 times minus 2 is plus 2 over 2, that gives us 1 again, and then it's going to be x squared to the power of 4. And then we're going to have a minus, and we're going to have x to the power 6, and that's us, plus 8, and then we're going to have 1 minus, that's n, x. Now wait a minute, what have we forgotten here? This is n, and then there's another minus here. So you need to remember that that's a minus there, right? Otherwise it would cock the whole thing up. Plus, and then we've got minus x over 2 squared minus x over 2 cubed plus minus x over 2 to the power 4 and so on. Right. Is that right? Minus plus minus plus. Yes. Equals. So now we're going to simplify here. So we're going to get x minus x squared times an x is minus x cubed plus x, now x squared, so that should be x to the power 2, that's an, the whole thing's x to the power 4, so that's x to the power 4 times another x, that's going to be plus x to the power 5, that's already too big, right, plus 8 times 1 is 8, and then we've got minus times minus, that's a plus, plus x over 2 times 8, that's going to be plus 4x. Then this is going to be a plus, and that's a plus, that's x squared over 4 times 8, that's going to be plus 2x squared. This here is going to give me a minus x cubed over 8, but times by minus is going to be plus x cubed over 8 times by 8, it's just x cubed. And then we've got x to the power 4 over 16 times by 8, so it's going to be x to the power 4 over 2, and then we've got other things. So join them all up. We have 8 plus 5x, that's that and that, minus x cubed plus x cubed, that's nothing, and we've got 2x squared there. And then x to the power 5 we're not considering, and we've got plus x to the power 4 over 2. That's the expansion to the first 4 terms, or to the power of 4 rather. What values is this valid for? Well, here's the two pieces of the expansion here. We've got 1 plus x squared, and we've got 1 minus x over 2. So we've got 1 plus x squared to the power minus 1. That is valid for x squared is less than 1. In other words, x is less than 1. And then we've got 1 minus x over 2 to the minus 1. That's valid for x over 2. You don't need to bother with the minus because you're taking the mod. So therefore the mod of x is less than 2. Well, again, we need to take the most restricted value there. We can't take that one because that would fall outside this bound here. So the whole expansion is valid for values of mod x less than 1. There we go. That's question number